So this is Year 12, Level 2 Algebra, solving log equations or solving using logs. This equation here, log 4 of 64, kind of looks awkward because it actually doesn't have equal anything. And we're going to let it equal, just for today, we'll let it equal P. Doesn't really matter what letter you use. It just helps you rearrange it because you need to be familiar with these sort of formats. Base power quotient, or log to the base of the quotient, equals the answer, and taking the log of both sides, and this one here where the power of the log can sit here or in the front of the log equation. So we've now put in this part here, and so we're going to use the format that the base 4 to the power of some number equals 64. And some of you can trial and error that and work out that the power 4 to the power 3 equals 64 pretty quickly. But then sometimes we get bigger numbers and we can't trial and error, it just takes a little bit too long. So using that same process, let it equal P, write it 3 to the power of P will equal 19,683. And this is where we're going to use the taking the log of both sides to help solve for that power. So we're going to have log 3p equals log 19,683. Bring the power to the front. Power log 3, p to the power of log 3 equals log 19,683. And rearranging it, p equals log 19,683. all divided by log 3, and that's when you grab your calculator. So log 19,683 divided by log 3 equals 9. P equals 9. And I challenge you also to put that back in here and test it. So 3 to the power 9 should give us that number. 3 hat 9 equals 19,683. The next one, looking a little bit more complicated, but the same process applies. Let this equal P. So what it's saying is the square root of 5 to the power of P gives us 1 over 125. So what we've got to do is simply rearrange this a little bit so it's a little bit easier to work with. So what I'm going to do now is think of the square root of 5 as 5 to the power of a half. Okay, so 5 to the power of half times P. So that simply puts the P on the top line. Now this equals 1 over 125, and then I'm going to take the log of both sides. Okay, now this power can live down the front. So P divided by 2 equals, log 5 equals log 1 over 125. So now simply finish off, P divided by 2 equals log 1 over 125, all divided by log 5. Notice I do not pick up my calculator until the very end. And dividing by 2, I'm going to have to multiply that whole thing by 2. So it'll be log 1 over 125 divided by log 5 times 2. So let's do that on our calculator. And we can do it in one go if we use brackets. So log 1 divided by 125. That's the first part. Divide that by log 5. Then we need to times that all by 2. And we should get the answer -6. So write that in. P equals -6. There is another way, and that's where we can change, given that this calculator log function is completely based on base 10, but we can actually change this to base 10 with our calculator. And that requires us to understand that anything log with a base of A, of a number, can equal log base 10 of that number divided by log of that base. So what that really means, and it's a lot quicker, is log 1 over 125 divided by, so this is base 10, log square root of 5 equals, and it'll give us the answer. So let's try that. So let's see that again. Log 1 over 125, log 1 divided by 125, divided by log square root of 5, log square root 5 equals -6. A much quicker way of doing it. So this is very handy in terms of being able to convert when you're calculating using different bases other than base 10. Alright, let's try it then on this one. This is base 1/4. So what I'm saying is if I do log 256 divide by log 1/4, then I will find the answer a lot quicker. So log 256 divided by log 1/4, 0.25, equals -4. So last one down here, on this side, log x minus log 3 equals log 6. So when we're minusing, we know that that is log x divided by 3 equals log 6. So this part here must equal that part there. So therefore, x over 3 equals 6. X equals 3 times 6 is 18. Doing another one though, but slightly more complicated. Log x minus 4, log x minus log 4. So again, that really means log x over 4, log x minus 4. So this part here must equal this part here. X minus 4, therefore x minus 4 equals x divided by 4. Instead of dividing by 4, multiply by 4 on the other side. So I've taken the 4 across. And now, putting my x on this side, I'm going to have 3x equals taking the 16 across, 16. So x equals 16 divided by 3, or 5 1/3. Last one. Solving something like this, not to do with logs directly. Actually, you have to sort of know your powers first, then you use logs later on. So I've got 2 to the power 3x times 4 to the power 5x equals 120. This can be written in terms of the base 2. That's what I need so that I can simplify this side of the equation. So I have 2 to the power 3x times, rewrite 4 as 2 to the power 2, 5x equals 120. Now, this here, 2 to the power 2, 2 to the power 3x times 5x, can be simplified as this, 2 to the power 10x, and this. Given I've got the same base, I'm now allowed to add the powers. 13x equals 120. Now we go to our logs. Take the log of both sides. Log 2 to the power 13x equals log 120. Next step, bring that power down the front. 13x log 2 equals log 120. Now I have 13x equals log 120 divided by log 2. And last thing, instead of timesing by 13, of course x will have to be log 120 log 2, divide all that by 13. Okay, so that's when we grab the calculator. Log 120 divided by log 2 equals, and then divide that by 13, and the answer is 0.513. 0.513. Sorry, 313. That's the answer.